Glasgow's philosophy podcast, which is Glasgow Uni's very own philosophy podcast. And today we're hosting a panel event about the philosophy of science. We'll be talking today about specifically the scientific method, and we have a couple of wonderful guests with us here today to do as such. We're going to be talking to Dr. Mike Hicks first, who is a professor at the University of Glasgow as well. And we'll be talking about a type of reasoning that we all do every day, even though you might not think of it as such, and specifically a type of reasoning that is, or at least seems to be, integral to the scientific practice, namely inductive reasoning. You've maybe heard of it. And specifically, we'll be talking about the challenges that David Hume brings to inductive reasoning and the impact that this has on science. We'll then speak to Dr. Azita Chellappoo, who is not here at current because she's taking the train from London and the train was delayed, but she will be here soon. She's in the taxi on the way from Central Station. But once she gets here, we'll be speaking about the role that social and political values play in scientific research, and more specifically about the question of whether or not it is possible to do science without undue influence from such values. This is something that scientists and philosophers of science most notably disagree on, so we'll be speaking about that. And finally, we'll be speaking to Ignazio Arrabito, who is here already on the end, who is part of a very exciting expedition to the Sandwich Islands, during which he will be researching the influence of strenuous conditions on research itself. We'll have roundabout of 10 minutes of question and answer at the end, so if anyone has a question, please save it until the end. Do keep in mind, we are recording this, so you have to live with what you said on tape. Yeah, so just to get us started, could each of our guests please give a brief introduction to yourself?
Oh, great. I'm Mike Hicks. I'm a lecturer in philosophy of science and technology here at the University of Glasgow. My research is mostly on the metaphysics of laws of nature, so that's kind of a big topic, but what I'm interested in is what makes things necessary. So some things have to happen. What goes up has to come down. It's impossible to go faster than the speed of light. There's a broad kind of philosophy, research area in philosophy that's trying to figure out what necessity is, but a lot of it's focused on logical necessity, the necessities that come from the meanings of words. I'm interested in how, the laws of nature, how scientific laws or theories tell us about, what is possible and what isn't possible in the world. And that's kind of the big picture of what I work on. Yeah, that's about it for me.
Great.
Yeah, that's what I do.
What about you?
Me, I'm just Ignazio. I don't have any title. I used to be a master's student up until this June in France. And I was part of this master course from which I graduated that's called Philosophy in Biology and Medicine. And it's basically a philosophy of science course that's extremely specialized into biology and medicine. And it's a way to do science that's very much scientific, to do philosophy that's very much scientifically informed. So I studied a lot of biology, and we basically tried to use our conceptual tools to help with conceptual issues in science and working with scientists on that. And during my latest period there, I started to look mostly on stuff like social aspect of science, so stuff like science funding, or for instance just experimental practice. And so I got interested into this other side. So I'm also part of what some people would call philosophy of science in practice. And yeah, that's about it. I will talk about what I will do as my next project later on. But it's still something that's basically looking at scientific practice and how it is influenced by its context. So, yeah.
Fantastic, and thank you again both for being here. Just to jump into a little icebreaker question, I figure it's philosophy of science panel. What better way to start than by doing a little philosophizing about science? So I'm curious, what do you view what is something that makes something scientific? And
Great.
how, if at all, has that been affected by your specific field of study?
Great. I think that what makes an activity scientific is that it's part of kind of a rigorous group project to find out facts about the world by interacting with the world. I think that that's kind of what science is. So I don't have a clear picture in my own mind of what the scientific method is in a way that kind of applies to every science and describes what each science does. But I think one thing they all share is that they're collaborative and they're trying to find out sort of empirical contingent facts about the world, things about the way the world is that you can only find out about by looking at it, by interacting with it. So that's kind of what I think science is. And it's kind of taking the way that we as individuals learn about the world and doing it rigorously as a group. That's how I think of science.
Ignazio, what do you think makes something scientific?
Well, I think I kind of agree with what he said, but I think that so basically one way to define science is just to say that's a form of knowledge, and it's specifically a form of knowledge that's trying to investigate the natural world and doing it in a way that's trying to create some sort of coherent, more or less, system of knowledge that usually wants to have a predictive power, because oftentimes when you do science you also want to get applications out of this. But I think that what's important also when you want to define science as it is a human activity is that you need to go into more of the practical side and just say it's a literature tradition. A practice tradition, and this is why when someone asks me what makes something scientific, because someone before him who was called a scientist said that this thing was scientific. So I think that although we might want to define science from like a conceptual point of view and just see it as this method and way of investigating the world, and by the way, I'm really I agree with what you said, that like there is no general definition of the scientific method because it's just so much variegated. But like, even though you can give this kind of definition, then like this is the whole point of view of the method, but then you also have to just look at like the tradition that's behind that, which is just much more practical thing. So.
Thank you so much for just medium interruption. This is Dr. Azita Chellappoo, who has just joined us from London. Thank you so much for coming. We're glad you're here. We were just discussing what everyone thinks science is and how that's maybe influenced by their field. Yeah, sorry, that's what you were saying.
No, I was done. Yeah.
Well, I guess we can pass the question over to you then. Sorry to put you right in the middle of it. Do you have what would you describe science to be?
Oh, well, I wish I'd heard the other answers. I'm sure will be better than my frazzled one right now. I think it's a difficult question. I suppose it will sort of depend on what you're drawing the contrast with as well. If you're thinking about science versus pseudoscience, like a classic way of thinking about it, or of course like science versus non-science, which is slightly different as well. I don't know, I guess I'm maybe sympathetic to a bit more of a sociological view and to think about, I think it's quite difficult to pinpoint in terms of sort of epistemic activities, things that are sort of common to what we intuitively want to call science and not present in what we don't want to call science. So, not very satisfying answer, but I think probably the way that I think about it is more in terms of think about what we call science and the kind of things that scientists do, rather than trying to find some sort of connective, like logical or.
Well, and I think that's part of the reason why we were so excited to be talking about the philosophy of science today. so excited to have such an incredible panel is that the philosophy of science is a field of study that is very interested in these kind of base assumptions and kind of rudimentary ideas by which we live our lives. A lot of some incredible work in the philosophy of science is done on some of the foundational theories and kind of practices that we would take for granted in our daily lives. I think one of those being the problem of induction. So induction or inductive reasoning is the practice by which you create generalized principles from sort of more specific observations and the consistency of those observations. So take, for example, the fact that the sun rose today. I knew that the sun was going to rise today because the sun has risen every day for me. And I know that the sun is going to rise for Tinka because I know her very well, and I know that the sun has risen every day for her. So by the process of induction, we're able to kind of generalize these principles and kind of essentially predict the future based on what we've seen in the past. And this is kind of a very core idea in a lot of scientific theories, is that through this inductive process, you're able to get these very generalized principles without having to quite look at everything to get there. But as early as the 18th century, philosophers kind of disagreed with that. So I'm going to turn to you, Mike. David Hume was very, very famously kind of took issue with this idea of induction. What was sort of his issue with induction, and what kind of logical holes did he find in this kind of foundational idea?
Great. So Hume thought of induction as being, just like you said, a process of generalizing from some observed instances to a whole population. And we do this all the time. So we do it when we make predictions in our ordinary lives about what's going to happen tomorrow with, the sunrise. Every science in some form does this. So we just all agreed, I think, that we don't think that there's one universal scientific method. But I actually do think at a really coarse grain, every science in some way employs this kind of method of observing what happens in a restricted sample, whether that's like the past, your past experience, or just looking at what happens in the solar system and expecting every other astronomical body to obey the same laws, or looking at how a medicine affects a special subpopulation, a specially chosen sample of people, and inferring that the medicine will behave the same way in the rest of the population that you're going to apply it to. So these are all kind of different, in the details of how sciences kind of employ this reasoning. It's different. And as you say, if you're contrasting science with non-science, a lot of times when we're not doing science, we also generalize from our experience, right? So it's not just a scientific method, but it is kind of, I think, a key part of science. And Hume thought that this method rested on an assumption, and he called the assumption the principle of uniformity of nature. He had two ways of describing it. One was, it was the assumption that the future will resemble the past, that future instances of some law will be the same as past instances. The other way he described it was as the assumption that those instances that you haven't seen will resemble the ones that you have. So the idea that once you've observed a sample, you assume that things outside of the sample will match it. And so Hume thought, that's what we're doing. That's the assumption we're making whenever we make predictions or extend our knowledge from an observation to the rest of the world, right? And he thought, his problem with this was just that he thought we could have no reason to believe in that assumption. And there's debate amongst Hume scholars about what his attitude towards it was. But the basic idea is that he thought we can have no reason to believe that the future will resemble the past. And his argument was kind of simple. There are two ways you could get a reason to believe that. One is through kind of a priori reasoning, the kind of reasoning we do when we're doing math, where you can do math, you can close your eyes and figure out, if you have 3 of one thing and 3 of another thing, you'll have 6 total things. Most of math can be done without actually encountering anything in the world, right? And Hume first argued, well, we can't find out that the future will resemble the past that way. because it's certainly possible that things will go different for any generalization you think of, right? Could be that the sun doesn't rise tomorrow. It might blow up. Earth might stop spinning for some reason. You don't even have to, I mean, when we imagine this kind of thing, we imagine there's some, when I said the sun might blow up, you probably thought, yeah, maybe there's like a mechanism in the sun that makes it blow up, or, you know, there's like something about physics that in the sun could make it go supernova. But that's assuming that the laws of physics will stay the same. But that's all part of the basic assumption that Hume's challenging. You don't even know that, right? It could be that it just like winks out for no reason, right? So Hume thought that is all those things are possible, so it can't be a priori that the future will resemble the past. There's no deductive argument for it. So then maybe we learn it from experience. That seems reasonable, right? So science has worked in the past. It's been very successful, I think. You know, there's some, we're not talking about realism today. Some people think it hasn't been so great, but I think generally science has done wonderful things for us. If you're watching the video, you guys in the room don't have to worry about this, but if you're watching the video, it's because the computer in the phone is working, right? And that's something that operates because of things we've discovered scientifically. So that seems like a really good reason to trust the inductive method, right? That it's always worked in the past. But those of you who are paying attention have probably realized that that would be a circular reason for trusting the scientific method. The fact that the scientific method has always worked in the past can only be a reason to expect it to work in the future if we're in some way licensed to assume that the future will resemble the past. But right, that's the very thing we were worried about. So that was Hume's problem. It was like, this is, there's no non-circular way to justify this method. And one thing I'd just like to emphasize before, you can jump in, but before you jump in, is that he thought this didn't just mean, because everybody, I think we all agree, scientists agree if you talk to them, that we can't be certain of scientific theories. They're probably wrong in some detail. Everybody thinks we have to improve science and we need to keep doing experiments because it's very unlikely that our current scientific theories are precisely correct, right? That's not what Hume is saying. That's just like kind of moderate fallibilism where we can be wrong sometimes. Hume's saying we have, not only might we be wrong, we have no reason to believe in the theories. And that's quite radical, I think. So, yeah.
Yeah, so this is what I was going to ask about, because I think when I first learned about this, I was really mind blown, because I was like, this is so crazy. This is like a type of reasoning that we all do all the time, and that we rely on to make things work, and somehow the world hasn't yet exploded. So surely there must be some truth to like us doing this kind of reasoning. So I wonder, can we maybe, did Hume maybe have some kind of idea of, okay, well maybe it doesn't give us certainty, but maybe it gives us some sense of like, well maybe it's more likely to happen. Like maybe if I've seen something happen like 60 times, then I may be correct in assuming that it makes it more likely, if not possible. Or did
That's a great question. He addresses that, but he was writing in 1738, something like that. And they did not have the modern mathematical rigorous theory of probability that we have now. So I don't find his arguments in that part super compelling, just because it seems like he's kind of confused about what probabilistic reasoning is. In the modern period, there are philosophers who have thought maybe statistical reasoning is a priori because it's math, right? And so maybe we can start with this like mathematical method, and then that is an a priori reason to get some probability. You know, if we're using stats correctly, we'll get some expectation for the future. And I think it doesn't work. I think even when you go into, you have to make some assumptions about which theories you're taking seriously in order to start employing the kind of mathematical mechanism of statistics or Bayesian statistics, whatever you're using. You have to restrict your theory space, and all the theories you consider are ones where all the theories you consider are going to be ones where the future resembles the past, or in some way your sample is representative. And we just kind of, usually when we're using those methods, rule out the crazy theories where, up until now everything behaves regularly and then it goes crazy, random stuff starts happening. So I myself don't find that compelling, but it is one, I think, pretty good and really interesting way of responding to Hume. And there are still living philosophers who think that you can, if you really understand how statistics works and why we employ it, it's a priori. Is that?
Yeah. That does it. I guess the trouble is that it's really hard to do any kind of reasoning without using induction at any point.
Yeah.
Because we were discussing earlier, we were thinking about like this example of if you throw a brick through a window.
Yeah.
And so maybe you can't use inductive reasoning in the sense of like, okay, well, I've seen other bricks been thrown through other windows, so probably it's going to break. That's induction, right? So not allowed. But
Yeah.
maybe if you're a physicist, you can be like, okay, well, I know I can use the laws of physics, and then I can use maths, and that's maybe allowed because that doesn't use induction. But then as soon as you use physics, you're using like these laws, and you're assuming that they will also apply in the future. And then there you have induction again. So it just is really hard to do any kind of reasoning without induction.
I like that example. So one of the things that I think, for me, that's really fun about the problem of induction and reading Hume is that it's not that the problem isn't solvable, it's that your response to it, I think, tells you something about how you think the world is and how science works. So the thing you described where you like see the brick go through the window, you see it break the window, and then you like use the laws of physics to figure out what will happen next or why it happened the way it does. That's, some philosophers think that's not induction at all. That's inference to the best explanation. And they're like, that's a different method. And what you do is when you see the rock go through the window, you see a causal interaction. You see the rock cause the window to break. You get to infer something made that happen. That's the laws of nature. And then those, because they make other things happen, they let you know that the future is going to resemble the past, because they're like making the future resemble the past. You found something that makes stuff happen. It's like the glue that holds the world together. And once you see the connections, then it's not like, once you know the laws of physics, you know the future, that the Earth will keep rotating, because the laws tell you what's possible. Mm-hmm. And one thing that I think is cool about this, and this kind of brings us back a little bit to my, my pitch of my research area about what's possible, is that idea is the idea that the world doesn't just consist of events that we observe. It consists of events we observe and then some other ingredient that's making those events happen and connecting them. And this is another answer. I'm a Hume, I like Hume a lot, and I think he was right about most things. So I don't think this works well either, for kind of the reason you gave, which is that in order for this to work, you have to still presuppose that the laws will continue to work the way that you've seen. And Hume kind of says that if you're reading it into him, I think he saw that a little bit. I'm not a Hume scholar primarily. I've read him a lot, but I don't know what everyone who knows what people were thinking in the 1700s think. But it seems to me like Hume had some idea like that. But again, a lot of philosophers think that once we see the necessities out there in the world, that will let us solve the problem of induction, because when we see what's making something happen, we can then employ that to predict the next thing, and that's like a handle that gets us out of this kind of circle. Is that, yeah.
I'm curious, how does this filter into the scientific world? Because like you said, a lot of scientific theories are built on this idea of induction. Yeah. To what level do scientists really grapple with that, or is that just kind of something they don't really consider? I've talked to scientists about it some. Yeah, I don't think it affects their practice at all, and I don't know if I think it should. So I'm glad that you have, I think a diverse panel, and I like that you have people who have more sort of scientific practice informed work in philosophy. Mine is kind of quite broadly philosophy based and looking at science. I think that what understanding the problem of induction does is it kind of allows you to see what things, if you like the statistical methods we use, are doing, and what the reason the method succeeds is. So my own view about how we should respond to the problem of induction is kind of similar to Hume's view, which is to say we don't have a reason to expect this to work, and even our past experience with it isn't a reason to expect it to work, but we're kind of stuck doing it. And in order to be agents in the world,
we have to trust that we can find out about the world through our interactions with it. And there is some degree of kind of trust falling into the world, and hoping that it continues to be the way it was and kind of catches you in the way you expect. But for me, I think that it is more informing us about the way we should understand the tools we're using than giving us a reason to actually change those tools. And Hume himself, I think, like I said, I'm not a Hume scholar, so I don't have a strong opinion about what he thinks, but I have some moderately informed opinions, right? I think that he also didn't think we should stop doing science because we don't have a reason to. I think he thought instead we should see it as an extension of our psychological habits. So he thought our brains are built to make certain kinds of inferences. And those inferences are ones like this, where we see something happen a lot, and then we form a mental habit of expecting it as a result of having seen it before. And he kind of thought science is like an extension of that habit, where we're doing it, he didn't put it this way, but I think we're doing it kind of as a group and more rigorously, and being more careful about what we count as an experience and writing it down in a way we can share. And so that kind of informs how I think of the scientific practice, but I don't think it should make scientists like stop doing this. I think it's a very successful method, and I expect it to continue working. Yeah. Hopefully, yeah. You gotta have your fingers crossed a little bit, I think.
Just a little bit. I guess that kind of brings us into the next part of our panel, because we're going to talk about another thing that philosophers and scientists disagree on, which is whether or not it's possible at all to do science without being influenced by political or social values. And so we'll be talking to Azita for that, because that's something that you have done a lot of work on. But it's kind of an interesting line in the sand almost, because I think similar to when you ask scientists about the problem of induction, and they're maybe a bit nonplussed, it doesn't really seem to affect their work that much. A lot of scientists do wholeheartedly believe that they are able to do science without being influenced by political or social value. And what's more, if you were to ask a specific scientist, they would probably venture to say that that's exactly the kind of science that they're doing. Whereas a lot of philosophers of science disagree, and with good reason, as we'll hear soon. And also we have a lot of examples from the past of science that we thought was done without interference of such non-scientific values, we can say, where actually it turned out later upon further inspection that was not the case. So one most notable instance of such a case is research into the sexual behavior of primates. So male scientists somewhere in like the 1960s did a lot of research, and it turned out later that they were very much informed, and in fact were projecting a lot of their ideas about the values of how humans reproduce themselves, and therefore had kind of projected things onto the primates that they actually weren't doing. And so that's a really great example, right, of science at the time that we all thought was really good, value-free, and it turns out that it's not. So all of this to say, this is quite a contentious issue, and the idea of doing science without those values is called the value-free ideal. So now handing it over to you, Azita, I would like to ask you, could you tell us a bit more about what this ideal exactly is?
Yeah, thanks. That was a really good setup. Yeah, so basically, like you said, the value-free ideal is the idea that science ought to be value-free. Maybe it's not right now, maybe it's often not, maybe it never has been, but that's like an ideal that we should work towards. And whatever you think that means, it probably you're thinking of the right thing. So, like you said, kind of non-epistemic values, the values that aren't to do with knowledge or truth, social, political, ethical, pragmatic values, shouldn't enter into the internal stages of scientific reasoning. So the bit in science where you're drawing a conclusion from the evidence, you're deciding, for example, whether to accept or reject hypothesis, that should be value-free. And so people on both sides, people who think that is a good ideal and people who want to reject it, both of them will agree, okay, values have got to come in at all these other stages. When we choose what kind of question we're going to investigate, so ethical restrictions on how we should treat, people in a clinical trial, what we should do with the knowledge afterwards, all that stuff, yeah, of course, our values are going to come in. But where the disagreement is okay, once we've, collected, designed our trial, collected our evidence, that inferential leap from the evidence to the conclusion, that's sort of the core of the disagreement. And I think, kind of as you said, I think it's a pretty, so in surveys of scientists, a lot of scientists will say, yes, science should be value-free. The ones who are a bit more aware will say, yeah, it's not value-free. I mean, a lot of scientists, I think, will think now science isn't value-free, right? We can complain about funding and all this kind of interest that, distort things, but nevertheless, ideally, right, this is the kind of thing we should be working on to eliminate our own biases. And I think there's sort of a public sense as well that that's a good thing for science to aim towards. But sort of the funny thing is that for almost all philosophers working within this debate just reject the value-free ideal. So you've got this kind of big disconnect between scientists and the public and philosophers. And I think basically the reason is, so the argument, the sort of philosophy of science argument is it's not possible, even sort of in principle, for science to be value-free, and there's a lot of arguments that have gone towards showing that. And so if an ideal isn't possible, then it's not reasonable or useful, so therefore we should abandon it. And the example you mentioned of bias in primates, I think you were talking about maybe from Helen Longino, feminist philosopher of science. A lot of feminist philosophers of science were really crucial in establishing that first premise I mentioned. So this idea that sort of at a fundamental level, it's just it's not possible for science to be value-free. So Longino has the argument for underdetermination. So theories always evidence always underdetermines the theory. There's always going to be values, are going to have to come in to kind of make help you make some choices. And maybe sometimes they're going to be, if it's sort of, particularly in medicine, right, or something like that, social, ethical values might come in a lot. But even in sort of less obviously sort of social, disciplines like physics or something, even what some people call cognitive values, so things like simplicity or something might make you prefer one theory over another. And philosophers tend to think, well, simplicity isn't sort of strictly epistemic, because just because something's simpler, that doesn't necessarily mean that it's truer or more likely to be true, but it's sort of has some kind of cognitive upside. So that's another kind of value that we can't eliminate. And a classic argument, the argument from inductive risk, this is very, very popular values in science literature, is basically this idea that when we're thinking about whether to accept or reject a hypothesis in a given study, we're always balancing the risk of false positives, the risk of false negatives, right? We accept it when actually it's false, or we reject it when actually it's true. And sometimes, there's going to be sort of non-epistemic social political considerations that are coming into that balancing. It's like a classic case. We're looking at whether a particular chemical causes cancer, right? Like how certain do we want to be, right? Where do we set that evidential threshold? Because on the one hand, if we say it does and it doesn't, well, then we're sort of over-regulating when it has economic costs and stuff like that. But if we get it wrong the other way, then that could cause all these harms to human health. And where you want to set that threshold is just going to depend on, how your own sort of, how you value those two outcomes. And really crucial to that argument is that you have to set that threshold somewhere, right? You're always trading off, right? One thing you can do is you can conduct a bigger study, so you can reduce your uncertainties, you can reduce your chance of false positives and false negatives at the same time by collecting sort of better quality evidence. But that's sort of, aside from that, if you're looking at sort of given set of data, you can only ever trade off between them, and that's why, in general, philosophers of thinking, well, in that sense, values always just have to come in sort of that kind of way, and so there's just, you can't eliminate them from science.
You make a really strong case there for the kind of essentialness of values in science. Whether we like it or not, they're going to be there, at least on some level. And a big part of your work is kind of looking into the value-free ideal. How do you propose to kind of reconfigure it, change it to make it more effective?
Yeah, so my position is I want to defend the value-free ideal, but the arguments against it are very strong. So it's a difficult project, and I think that part of the problem is, so on the one hand, you have I've mentioned a couple arguments. There are really so many arguments about the ways that values must come into all kinds of parts of science. The way we classify things, sort of underlying ontology. In our concepts, there's like sort of thick concepts of facts and values are just intermingled and can't be separated. So like well-being, or less obvious ones than that too. But all these arguments are really strong. But then on the other hand, I think still, nevertheless, the value-free ideal has this really intuitive pull, maybe especially in sort of our current sort of post-truth world or something. When you think about it's kind of anti-vaccination, or you think about climate change denial or something like that. At least for me, I really want to say what's going on is it's not a liberal set of values versus it's not a moral political disagreement. I sort of have the intuition it's a strategic mistake to kind of reduce it to something like that. And similarly, with the example you mentioned, Tinka, about primates, I think what's really powerful about those feminist analyses is that they sort of exposing all these biases, kind of androcentric biases, right, in this research, in a way, to me, the most natural way to think about that is that those biases were distorting that research. They were producing sort of less fruitful knowledge or less true things. And by sort of looking at things in a different way, we actually, we're doing better science, not just, so not feminist versus non-feminist science, but just better science, which, thanks to the intervention of feminists. So my sort of proposed solution is to sort of essentially to redefine the value-free ideal a little bit. So the sort of typical standard formulation that I mentioned earlier is just that non-epistemic values should have no influence on the reasoning of scientists, the reasoning in these internal stages. And I completely agree with all the arguments that just is not possible in that sense. But my sort of way of rethinking it is in terms of the value-free ideal is achieved when non-epistemic values aren't hindering or distorting the expression of epistemic values. That's kind of a weaker way of formulating it. So for example, if you've got two sets of values and they would lead from one set of evidence to two different conclusions. So under the standard value-free ideal, that's, you've not got value freedom because you've got two options based on what values you pick. But under mine, that could still be value-free if those two theories are equal in, let's say, explanatory power, predictive power, or whatever sort of combination of epistemic values that you want. So you might still have difficult choices. So it doesn't eliminate those difficult choices. But one thing I think it does is it helps you sort of pick up on, so more clearly separate the sort of bad science, the biased science, from the not. So a case that I've looked into is sort of this like rise of race science and hereditarianism. And I think when you look at maybe some of the more, some of this sort of philosophical stuff, values and science stuff, I think it's tempting to go down this route of it's sort of a moral thing, right? They're coming at it with a certain set of values about race, and we need to combat it with a different set of values, of anti-racist values, and I mean, it's certainly true, I think, in that, that values are driving that. But then when you look at the actual scientific criticism, the scientists that are trying to push back against these sort of race realist positions are doing it not on value-based grounds, they do it on epistemic grounds. Okay, look, you know, you've got this biosampling, this is how you've done this, they're pointing out all the ways in which that research is falling short of expressing kind of epistemic values or living up to epistemic standards. So I think that thinking about it in that way is sort of more, we can recognize the influence of values in science while still being able to sort of differentiate or identify cases where values are distorting knowledge.
It sounds like what you've done is you've made the ideal a lot more practical. Like, there's a sense in which it's a lot easier to apply because you're kind of giving a benchmark for the kind of thing we're looking for, right? Because you're saying, like, if you do your science different ways with different values and you arrive at different conclusions, that points to the fact that your research is biased. But if you do your science and it's maybe still influenced by values, but you arrive at the same conclusion, then you have clearly picked out some kind of true thing about the world, and it's not been influenced by the values in, like, maybe in some way, maybe as you said earlier, like, values will always come in when you're trying to choose the research question, for example, but they won't have come in like any integral part of, you know, what evidence you choose to consider. So it sounds like it's just a lot more practical, and also if you then try and think about how you would implement value-free ideal in maybe, like, you know, some kind of like science commission, or if you're trying to like actually, you know, do it in practice, it gives you a really good way to do it, whereas before you have to then do kind of this very specific analysis. And if you think about it, like, what these feminist philosophers of science were doing is kind of, they were showing kind of that if you do the same science with a different set of values, you come at a different answer. So in a way, you really, picked out something quite, integral to the question. But actually, I just wanted to ask earlier when we were talking about what philosophers of science have to say about the value-free ideal, so not yours but the older one, is you do have some people who sometimes say that it would maybe be wise to keep it alive as like kind of a useful fiction, is the term people use. So they're like, well, you know, it's good to have that as an aim, and you might not arrive at it exactly, but, you know, it's good to try at least. What has been the response to that? People saying that's a good or bad idea?
Yeah, thanks. Yeah, exactly. So, in terms of other ways of defending the value-free ideal, there's a couple of ways you can go. You can try to say, well, maybe it is possible actually for it to be value-free, and a couple of people have done that, but it's pretty difficult. Or you can say, well, okay, maybe it's not possible, but still an impossible ideal can still be useful. I mean, we can kind of, sort of pretend to the scientists that it's still the case. And I'm not unsympathetic to it. I think probably people say that because it really, we really do have this feeling like, you know, it's an important thing that we want to uphold, and then it's sort of struggling with that that tension of all the arguments showing it's not possible. But I suppose the reason that I'm not a huge fan is sort of, firstly because I think maybe just my own orientation. I mean, I come initially from a science background. I think sometimes philosophers have the sense of, okay, we know it's not real, but, you know, they can go on acting like it's a sort of false consciousness, which I think is probably not very helpful, and not, you know, I think because a lot of scientists will express these ideas, and so I think, you know, it's sort of better to look at kind of, or what is it they think. I think they're probably not thinking something that's hopelessly contradictory. And in theory, I sort of see my attempted re-articulation as more like, not novel, but just more reflective of actually how scientists and maybe how the public sort of thinking about the value-free ideal implicitly. But yeah, so you kind of, the idea of this useful fiction, I think it's also just a bit, I mean, people talk a lot about sort of one of the reasons for wanting to keep the value free ideas of public trust, but I think if you are sort of committed to upholding a fiction in the long run, that's, you know, potentially even more damaging to public trust. And, you know, I think in sort of potentially kind of anti-democratic as well. I think fiction democracy we shouldn't have.
Yeah.
So trying to maintain, these lines, which I'm sure that are pretty easy to see through. Yeah, so yeah, I can understand the impulse, but I think if you have another option, it's preferable. Yeah.
It's almost like a last resort. I think people find this idea really, really hard to abandon because it seems like, well, if we can't do science without being influenced by values, then we're lost. Like, then how can we ever know what the truth, capital T, is? But yeah, I think with your ideal, you propose a very good way to at least try and get at a truth that at least is not distorted by political values.
And that kind of brings us nicely into what is our last topic of the panel. So Ignazio, you are planning and taking part in an expedition to the Sandwich Isles, where you're going to be kind of using, at least in part, a lot of the kind of foundational ideas and issues that we're talking about today, but we're going to see them in action. Could you explain a little bit about what your expedition is going to look like, how you got involved, and what you're going to be doing?
Okay. So back in August of last year, I got an email at some point of this girl that was recruiting people for a research project, and I remember me just like skimming through the email. It was like, yeah, research projects. We also look for scientists or also humanities, blah blah, to go to Antarctica. And I was like, and I started reading the email for true, and turns out that was an association of which I'm part of now, and it's an association that organizes. It's a student association. It organizes research and awareness campaigns on environmental sciences, and particularly the next project, which is the one that I'm going to be part of. It's this sailing expedition that's going to go from La Rochelle in France all the way down in the sub-Antarctic region to the South Sandwich Islands, which is this volcanic archipelago. And we're going to cross through different islands, and the main idea is to do research on one theme, that is the influence of climate change and anthropization on insular environments. And it's an interdisciplinary expedition. We've got a volcanologist, we've got a physical geographer who is studying glacier melting, and we also got an ecotoxicologist who is studying basically human pollution, just to see how far it can actually get. And then there's me, and well, we also have got an artist who is doing a documentary on the whole expedition. But me, what I am doing is basically what was interesting for me. I've always been interested into experimental practice and how the scientific method is much messier than you make it look like when you just go like, hey, hypothesis, and then, well, observation, hypothesis, and then testing, and how the scientific method can be much more varied depending on what you actually want to do, because this idea of observation, hypothesis, and then testing is basically what philosophers of science usually take from molecular biology, which is this like field that's overstudied. Well, not overstudied, but it's just like the main field that's been studied by philosophers of science over the years. And so I was interested into seeing how does these all work into an expedition that's doing stuff on environmental sciences, so no molecular biology, on a boat in a place where there is 15 meters waves sometimes, so you don't really get the comfort of a lab. And so this is what I'm going to be doing there. Basically, I'm going to be studying and trying to understand how the scientific method and scientific practice is influenced by this context. And actually, there is also an aspect of value-ladenness in all of this, because we are also doing an awareness raising campaign, and our data are gonna be fed to the International Panel on Climate Change. So this is a research that's pretty heavily policy aimed or driven, directed. Yeah, you got it. So there is also this context that's interesting to look at to see effectively how this changes, but the method. But for me, the very interesting thing is how the extreme conditions can change all of that. Yeah, that's the general thing.
So I'm very curious to know, how will you conduct your research? Because I feel like usually a lot of areas of science is very clear. You're either in the lab or you're at your table, you're in the armchair.
Yeah.
How are you going to conduct your research?
So basically, on the one side, there is just like doing homeworks, so just reading a lot of literature. This is mainly to inform myself on the basically the epistemic culture of each different field, where an epistemic culture is this term that was used by, not Franklin, I don't remember her name, but this sociologist that basically was describing the different ways in which different groups of scientists and traditions of scientists would have different kinds of scientific practice. And so this is going to be basically the groundwork, studying each different topic and each different tradition, and especially in regards to what is the studies that have been done around the South Sandwich Islands, or for instance what you do in bases like Antarctica. But then there is ethnography. And so ethnography is basically this method of the social sciences that's basically a way to gather data through observation. And so the idea, well, it's part interviews, structured or semi-structured interviews, depending on what kind of framework you want to go there with. And then there is just like observation. And the observation for me is going to be mainly about what they do in the boat, but also it's going to be about what happens in, for instance, the research bases that we go through, because we do need to interact with the research bases of the different islands where we go through. And so this is, for instance, one already interesting target for me, because when you usually look at the scientific method in a really isolated ways, as just like this guy who has an idea of like what happens if you do this and then just tests it, this is like a really non-collaborative way of looking at science, while science is extremely more collaborative. And so, for instance, how does the exchange of data, material, and knowledge in general affects our expedition? Because we are isolated on a boat, but then we're going to go into contact with these different scientists. Or, for instance, still looking at data, how do we use the data that are deriving from basically, for instance, satellite images, and how do we integrate them with the data that we can gather there? Because there is a factor of not being able to gather all the data that we want for various different reasons. And so you need to integrate these two. And this just like makes it look like the, again, linear path of observation, hypothesis, testing is just totally crumbling, because you have so many other things that go around. And already in a lab you can see this, but in a case study as specific and as curious as that, I think I'm gonna find cooler stuff. So
I'm curious, because another important factor of that kind of cycle is replicability.
Yeah.
It's a big part of science, is being able to kind of redo a study and get the same results.
Yeah.
But when you're heading into kind of extreme conditions, you're saying these expeditions cost money, they take a lot of time to plan, you may not actually get to go back and recapture that data.
Yeah.
How does that affect kind of the way you format a study? Does that affect the data quality of the study?
Yeah. So this is interesting, because the thing is, for instance, the first time that I talked to these guys about basically what was because the context of the replicability ideal was really strong for me to get interested into this project. And I remember I talked to this about this to the guys of the expedition, and there were in front of me the biologist and the volcanologist, and I said, have you ever heard about a replicability crisis in the sciences? And the biologists went like, yes, and the volcanologists were like, what? And so the idea is that replicability, that is this idea that if you can repeat an experiment within the same conditions, meaning the material, the conditions, for instance, of the culture that you're doing, the just manipulation. So as close as you can get to the original experiment, if you do repeat that and you get the same conclusion, then you're validating the first conclusion. And this is a thing that's pretty common in molecular biology, and there is, for this reason, the fact that like apparently we are discovering that a big chunk of our discoveries in that field, they are not really well replicable. But the thing is that this is not an issue in other fields, apparently. And this is because there is many other fields where, for instance, they don't really do that many experiments. So, for instance, the ecotoxicologist there, he's just going to take measurements. He's going to take like feathers and feces of penguins, and what he wants to get out of this is basically a description of the amount of pollutants that are in the area. And this is still doing science, even though you're not getting that hypothesis out and you're not testing it. And the thing is that, therefore, replicability maybe doesn't even matter. And the more maybe important thing that I would highlight as a difference between what you can do in a lab and what you can do in this condition is just the idea of control. Because the idea of a lab is that you create an environment that's isolated from the rest of the world, and you take one object that's interesting for you, and you can basically section it into different parameters. You can fix the parameters that are interesting for you, that are not interesting for you, and then you can move around one of the other parameters and see how the rest of the system reacts. And this is how you test an hypothesis. You intervene onto the system that you're interested into. And if you move A, then you see what happens to B. So you can't do that in the wild, and you cannot definitely do that in a place where, on one side you don't have the possibility to isolate parameters, on the other side you don't have the possibility to summon these parameters whenever you want. Because one thing about doing science in a lab is that you can repeat the experiments as many times as you want. In the wild, if there is like a storm when we're going there and we didn't finish taking all the feces of the penguins that we could, that's it. That's the measurements that we got. And so here raises the question of what is a contribution of value in science, and the answer, I think, it really depends. And for instance, one thing that I talked about with a scientist who has been doing a lot of these kinds of expeditions, he told me, I did a lot of really, really bad data gathering, and I got really famous for it. Because I went to places where people were not going, and so those data that you gather, even though they are of low quality, because, for instance, there is the wind, because you don't have much data, because of different reasons, they are still very, very valuable. And so, yeah, I mean, I don't know how this works in the context of this expedition. This is what I want to discover. But this is like really what fascinates me, that you can very easily break through the like stereotyped ideas that usually you find in philosophy of science when you find people that only go towards the same case studies. So.
Another thing that I was wondering about is obviously because you're researching how strenuous conditions will impact these researchers and their specific activities. Are you concerned about the strenuous conditions potentially also influencing your research?
When we were preparing when we were talking a bit about what the kind of questions that would pop out would be, this was one of the questions, and I told you I don't have an answer, I still don't. I think there is of course a factor of, because between the different factors of contingency, there is like because there is natural contingency, there is bureaucratic contingency. Maybe they just like tell us you can't get in here. This is a marine protected area. Fuck off. So yeah, between these different things, there is also psychological pressure that you just undergo in these conditions, and that might be an issue, but it's mostly an issue because of like there is this idea that when you are doing ethnography, you should understand what's your position in the social like structured network that you are studying, and it's pretty easy when you're doing like 1 month of study of ethnography and you don't get really involved with those people. You can pretty easily create like a distance between you and your object of study. You can't really do that when you're doing 6 months in conditions that are really strenuous. So I think that this is actually what is gonna, like if I want to be as technical as I can, because of course like stress, yeah, but this is like something more general. If I want to be more technical, this is gonna be an issue. How I can actually interact with my object of study while being part of the object of study. And in a condition that is gonna make me much more engaged with it. And I don't know, like.
I guess you'll find out.
Yeah, I guess so.
And I'm curious, because you've talked quite a bit about science as kind of a collaborative process, and I think you've all echoed that idea on some level, especially when you're so, like it's a pretty unique spot for a philosophy of science person to be so closely connected to the science itself. What does that sort of collaboration look like between philosophers and science, and what is, I guess in a broader sense, what is the role of philosophy in kind of the scientific process?
I think there is no broad answer to this, because I mean, I've been, like, as I said at the beginning, like my master's degree is a master's degree where like the teachers are usually collaborating with scientists. And one thing that came out of both them telling us their stories and us doing like internships where we were actually trying to collaborate with their scientists is that it really, really depends on the people and the project. Many times, my impression has been that scientists just disregard whatever we have to tell them. And many times I got the impression that we just disregard whatever are their problems. And sometimes instead, for instance, it's really convenient to have a philosopher of science on the boat because you can argue for interdisciplinarity of your project, and this of course gives it value. But it's also interesting because it's really a matter of how much distance you have between the two disciplines, and I think that philosophy as it is, so for instance, these scientists in the boat, they collaborate, and like both of them knew, like for instance, there is a physical geographer and there is volcanologists. They both know about chemistry and they both reason in terms of chemistry because glacier melting as well as volcanic degassing have something to do with chemistry. Me, no, I don't have this. And on the other side, I know a lot about what they do, but I'm not doing what they do. So there is this sort of like outside perspective that I think is useful, because I think that what we have as philosophers as an advantage over scientists in helping them doing science is that we have more time to read, and we literally have more context of what they're doing. Context both in terms of scientific context, so there just might be the fact that they are so much over-specialized, which is normal, that they just don't know about other theories in their field or other studies in their field. Or there is like a more cultural or socio-political context, like for instance the question of values in science is extremely relevant for this. Scientist would be, it would be more difficult for him being inside of the environment to actually notice this. So I think that this is really what philosophers can bring in.
Sorry to interrupt, just checking, do you guys have food in here now?
No.
Awesome. No worries.
If we had food.
Do you have food?
For
We did not
myself,
provide snacks.
yeah.
Yeah, no, I don't. He was probably just hungry.
Sorry, continue.
Yeah, and I was saying, yeah, so there's this really idea of coming from outside and being trained into conceptual issues that can help with broader framing and context. but it's really difficult. You need to study a lot of science and to really understand what they are asking for, and you need to find the people that are open to this, because many times they don't, and it's just a matter of academics, not just like scientists, but just like even philosophers are like this. So.
Did you want to say?
Yeah, what you were saying, Ignazio, reminded me of one of the kind of, I don't know, questions about the reliability of the scientific method that I think about sometimes. So Charles Taylor and Ian Hacking both kind of had this thought that there's something different about sciences that study people, sociology, history, things like that. And what's different is that the objects of your study can understand your theory. And that might influence their behavior. Hacking called these like looping kinds. The idea was like, you know, if you're studying, one of his examples was homosexuality. If you're studying homosexuality, you apply a label to a group of people, they might take ownership of that, and then it might influence how they behave socially and politically, and it might, in some way, maybe undermine your theory or prevent your predictions from operating the way they do. And I think the worry you have is slightly different, but it seems kind of connected, that if you're too close to the scientists and you don't understand your distance from them, is the worry that you'll like influence their behavior, or that you just won't get the right kind of data yourself that you need, or
I mean, in the end, this one way that like usually sociologists describe this kind of approach is like a reflexive approach on the research itself. So since I am part of the research, I am somehow studying myself as well. So I think that it's just a matter of like where you draw this distinction from the beginning, from the social network that you are inside of. And if the distinction that you draw is there is no distinction because you are inside of it, then you do start to actually look at things in a way that's like you're looking at the interactions between all the different actors inside that network, you and as well. And of course, this is like controversial because you might say you're biased in how you describe yourself, but I mean, like, everything is biased. Well, I mean, there's a simplistic way of saying it, but I mean, that's, yeah, I mean, that's definitely true. And I still haven't studied enough ethnography to, like, know better about this. We are working on that with my supervisor, so,
cool.
Yeah.
I guess there's maybe also this idea of if you're on this boat with the same people for 6 months, you obviously will build some kind of a relationship, and maybe there's this idea of because you know them, they will maybe even be more honest, and maybe that will even be better for your science because you have become a person of like a person of trust, in a sense that they will maybe be even more honest about like, well, today I had a really rough day because the wind blew away my penguin species and that was really hard. So I mean, I guess it's hard to say because as soon as you enter in an actual relationship with the person you're studying, that could go either way, right? But potentially it could be beneficial.
Yeah, I mean, if you want to ask this question in a context where it's like more serious and more studied, just ask psychiatrists, for instance, or psychologists. But like, yeah, really, there is, for instance, this issue in psychiatry that's, psychiatrists told me about is that, you know, you learn how to ask questions in a way that they don't understand what's the actual question, that you're studying them, evaluating them, but they learn that you're doing that, and it becomes a catch-up game. And so like there it's really like even more of a dialectic, how do you say that, dialectic,
if it's the thing where your investigation influences their behavior, Charles Taylor called that the hermeneutical circle.
Yeah, okay.
Yeah, okay.
I know, I was just talking about like dialectic is just, it's
the dialectic between you and
dialectic, sorry. And like there is this dialectic that's very strong in the field, for instance, of psychiatry, and there is like a aggressive dialectic, effectively, it can be, and in my case it's more relaxed, and it's easier because it's just like matter of like effectively understanding what's my position in respect to them, but there is no necessarily not like trying to put a foot on the other person. But it's a very interesting question, this one. Yeah.
Maybe,
go ahead.
maybe in ethnography, I mean, not something an outside to it, it sort of sometimes seems to me like maybe part of why reflexivity is so important as a tool is because you seem to have to do a lot of sort of interpretation. You really have to pull the data out of itself, right? To kind of, like in a way, like there's where you might sort of decide, for like a quantitative study, like I'm going to look at this outcome. So maybe the outcomes that you picked are, driven by values, various ways of thing. But that's, someone can kind of look very clearly at that, and if they disagree, they can say, well, I would have picked different outcomes, right? But sometimes when I read ethnography, it's quite difficult because you've got this like sort of really thick, rich data that like the research, it feels like the researchers themselves have done so much work to even to sort of make that data, right, to pull those themes, to draw those interpretations that they're sort of really embedded, not just in the conclusions that they've drawn with the data itself, in a way that's quite hard to then, maybe just me as a non-ethnographer, to sort of then for me to identify, okay, like, where is like, where is the perspective coming in, or like where is the interpretive, the sort of individual perspective,
Okay.
or where's like the interpretive work?
That depends on how much of a framework you want to have before going into the observation and how much observational you want your study to make. That really depends on different people. In the end, there is also this idea in philosophy of science that even seeing is interpreting. So there is just like an inescapable level of subjectivity when you do something like this. But you can do ethnographic work that's really just like, you really describe in a really precise way whatever you say. And this somehow makes it more objective, but also makes it less theory rich. So it's really where you want to strike the balance. I try to be as descriptive as I can when I do my studies, but I agree that it's difficult to find like the fine line of the interpretation, but some people can really try to make this line as sharp as they can, even though it's never going to be that much sharp. So.
One thing I also thought hearing that part of what your methodology involves is figuring out how you yourself are situated in the social group was it just reminded me of some of the things you were saying, Azita, about how as scientists, when we recognize what our values are, we need to try to figure out how to control for those in some ways. And it's interesting to me that ethnography has this like methodological norm where you're kind of expected to figure out what your relationship is to the people you're studying and talk about it in your paper, probably to control for some of the biases that will. I didn't know about that at all.
It's like also a weird thing because like when we interact with people of the expedition, we're not saying something like, we want to do this because it's cool, it's going to give us good CV and etc. No, we're saying we're doing this because we want to save the planet. So there is a clear value-ladenness to the project. At some point we also had this discussion, hey, do we have like a political association? Is like our association partly political? And some people were like, no, we're actually this, and me and other people were like, yes, like it's clearly political. So I mean, that there is definitely value-ladenness in all of this, and it's even stronger.
That reminded me a little bit of one thing I found striking about what you were saying, Azita, is that you said that it's a strategic mistake to say that, to reject the value-free ideal. And I wonder if like kind of both of these things are building on the fact that like since the rise of kind of climate science as a central research topic and a thing that's central to our everyday lives, things that are really just science have become heavily politicized.
Yeah.
And we kind of have to figure out how to deal with that.
But science and culture have always been politicized.
Yeah.
So, like, for instance, I mean, I really like when people say like science should not be political, I think about the atom. Like,
Yeah.
and not so much about, because people are just like, yeah, weaponized, not just that. I mean, think about how much the rhetoric of the
USSR.
Yeah, USSR. Sorry. The rhetoric of that was the one where like science was driving progress, and this was reinforcing the political regime, and this was all based on nuclear energy. And then think about what happened after Hiroshima and Nagasaki, where somehow molecular biology just boomed in the US because everybody was just using this rhetoric, well, the government was using this rhetoric of atom for life. So their science was really being used to effectively discharge all the weight that was on top of the government, and in a way that would still give legitimacy to the government and the science that it was funding. And this is how we got the basically biggest field of science that we have today, which is like biology, because now biology is arguably booming much more than physics. So, arguably.
Yeah.
I actually don't know what the funding situation is actually.
There is a lot in biology.
Yeah.
I suppose science will always be political in the sense that humans will always be engaged in politics whether they realize or not, because every facet of our life is politics. But anyway, we'll end on that note. Thank you so much for being here today, for speaking with us. Can we all have a big round of applause for So thank you for being here. And now we'd like to open up the floor to our other guests. If anyone has any questions, now is the time to ask.
Yeah, I'm really curious about the difference between scientific and non-scientific thinking, but also philosophical and non-philosophical thinking, and when we determine the difference between that. Because I think with deductive reasoning, something that I was thinking about across all the really different elements of philosophy of science in this talk was as humans, I think we're endlessly surprised by the fallibility of deductive reasoning, and I'm thinking about between relationships between people, you base that on assumptions you've made about that person and a character profile you've built without even realizing it, and then all of a sudden that profile can be knocked by something that happens that's completely unexpected, but they also react to it unexpectedly based on what you've compiled of who you think they are, which you've not even done in a conscious way, it's just happened. But when that happens, not only do we not mistake or think that our deductive reasoning is false, we're just kind of surprised, and that can happen across a lifetime with several different people in different contexts. We also don't then assume that deductive reasoning is false. We don't then, because this deductive reasoning made about this person is wrong, then assume or stop assuming that the sun won't rise, or that anything, or gravity won't exist. So I'm just wondering, how do we know the difference between these types of deductive reasoning? How do we know where the deductively reasoned conclusion that we've made or drawn is deductive in the right way? And then does that not suggest that I don't know that then, because I think using that deductive reasoning isn't just to do with the scientific method, but it is part of science. But then couldn't you flip that and then say well, if everything is deductive reasoning, then everything is science? So then I'm just curious how we actually define these boundaries and I'm not sure what the question is in there, but I felt there were a lot. I don't know, there's a big question mark on my head.
Yeah,
I think you should go.
great. So I think inductive reasoning is deductive reasoning is the reasoning we use when we make predictions once we already know a theory, because we're deducing. But inductive reasoning is the word for when we're kind of taking the observations and finding the theory, and it's fallible, as you say, right? So I think that there's no hard barrier between the scientific inductive reasoning and the normal everyday inductive reasoning. So one of my favorite 20th century philosophers, Quine, Willard Van Orman Quine, I think that's his full name. He thought that there was a continuum. He thought that scientific reasoning was just our everyday reasoning done much more carefully. And so he kind of thought there's a continuum of reasoning, and then the more kind of carefully you make observations, the more sort of scientific it is. And one thing Ignazio was talking about was how when we have a laboratory, we can really control for a lot of features, and then we can isolate just one thing and see how that affects the system. And then we have sort of very precise knowledge about this one factor and how it affects the system. But when you're in the wild, you can't do that. So you make observations and you kind of roughly infer with less confidence about what will happen. And I think kind of a little beyond that is when you make a generalization about your friend based on their past behavior. There's some reason to think it'll continue in the same way, but there's so many factors that you haven't really isolated. I do think all of these rely on the idea that the future will resemble the past, that the patterns will hold, but what we're doing in science is getting really specific about the patterns we're looking at. We're like looking at all these different factors that could be causally relevant and seeing how precisely they vary relative to one another. And I think a lot of scientific practice is in shielding our system from outside influences so we can isolate one factor, measuring really precisely how our setup is, and then measuring really precisely how the outcome is to try to look in as fine detail as possible about how this thing might vary with that thing and how that pattern or causal relationship might work. But I think first it's all fallible and that you do have more security when you have the greater detail, and we're not able to do that in our ordinary lives. But there's not like a deep difference. Does that help?
Yeah. I think
Yeah.
so, yeah.
You guys, go. Yeah.
Just one thing, peer review.
Yeah, actually that's great. Yeah, so another difference in science is collaborative. So you have someone else checking your work, and replication is part of that, but peer review is another part of that, where in order for something to be scientific, you're putting it in front of a community that's checking it. And there is something like that when you talk to your other friends about why the one friend acted the way they did, but it's not nearly as rigorous or specific, I think. Yeah.
Also, peer review can be quite not as rigorous as you would like to, because it really depends on who is reviewing and how much power that scientist has, and yada yada. So you could blur the line even there, but it's definitely something more structured than you talking to your friends. But
Yeah. We also have peer review in philosophy, but it's they're mostly kind of looking at is the argument valid? What's the reasoning here, and does it reference the literature that it's building off of in the right way? Whereas I'm hopeful that in science it's similar. It's like checking that you've done the right methodology, but the methodology is maybe more
usually just about the quality of the data, the credibility of the method.
How exciting it is.
Exciting it is, yeah.
That's
And
true in
if
philosophy
other
too.
people are already
Yeah.
that-
Is this a really exciting argument? Or?
But and also, like we've already discussed, there's such a diversity in scientific method as well. Because I feel like when you think of science, you think of these lab experiments where you do have 1,000 data points or something. But there's so many sciences that are more historical. I think cosmology, but about paleontology and stuff like that. A lot of, even in developmental biology has those aspects, evolutionary biology, where it's totally different because you just have one, right? You have one fossil, and so you're using you're reconstructing the tree of life in a similar way, I think, than as historians do when they sort of build narratives, which is kind of pretty different in how you go about that compared to a clinical trial or something.
For instance, the difference between predictive and historical sciences, once you learn it, is very simple, but it also blows off your mind because you're not really trying to predict anything, you're literally trying to reconstruct a story, and you're trying to create the most credible story possible, given all the traces that you still have. And that's really fascinating, I think.
Do we have any other questions?
I would just like to know what you guys think of experimental philosophy. Is this a new application of science? Does it count for something distinct? Or is it just psychology writ large on philosophy?
Ignazio, do you think you're doing experimental philosophy?
Yeah,
No.
so-
Okay.
I
I was wondering that during your talk. Yeah.
No, to be honest, I barely know what it is. And
sorry, just briefly, I was going to ask, what is experimental
Yeah.
philosophy before we start on the tangent?
Roughly, I think Josh Nob's idea of it, at least I understand, is just testing it's kind of like psychology and sociology, I guess, because you're just testing people's assumptions against themselves. Like, you're actually like testing people's intuitions. You're going in there and seeing what are people intuitively thinking about these thought experiments.
Interesting.
Yeah.
One example which I kind of like is that, you've probably run into the trolley problem. Many of your viewers have probably also, because it's like now part of the culture. People read about it in the newspaper. But the trolley problem, it's like a thought experiment where it's like, if you're in this situation, do you pull the lever and have the trolley run over one person to save the other people? And in the philosophy papers on it, early ones, the paper presents the thought experiment and then says, don't you think that you should pull the lever in this situation, right? Or not, depending on how it's. And one criticism of that method as a method for philosophy is it's just asking like philosophers what they think, and we're a biased group, so it might not be representative of people's actual ethical views. And so doing some psychological experiments where you test people on this and see what they're really responding to in the situation seems kind of reasonable to me.
you just say psychological experiments, so you don't consider this philosophy, right?
Yeah, I think it's kind of borderline. Because I don't know. What do you guys? Let's see. I think about it.
I think it's fine. I mean, I suppose I'm not defending this, but I suppose it also depends on what role you think intuition, how you think about intuition and philosophy. Because maybe I think some people would say, well, you should ask philosophers because they're the intuition experts. You don't ask just anybody. Ask people that have. I think, I mean, it's definitely, I think, a good point, like a good corrective for some kinds of moral philosophy to, if your argument relies on an intuition, it seems important to figure out if it's a common intuition or not. Right?
Yeah, I kind of think what the doing philosophy part is kind of constructing the argument. And then you got to start somewhere with an argument. And where do you start? Well, ideally with things that you think your interlocutor, the person you're arguing with, will accept or agree with. And one way of doing that is to just kind of guess that they have the same feeling you do. But it seems, reasonable to do some studies, but I kind of think that the psychological studies are highly relevant to the philosophy, but I don't know if they're, there's not like a clean division, but I don't know if I would count them as philosophy exactly. I don't think it settles the matter. If everybody thinks one thing morally, I don't think that means that's correct, for example. And I don't think Josh Nope does either, actually. But,
I feel like intuition plays a very interesting role in philosophy, specifically when you think about the fact that philosophy is a doctrine that thinks of itself as, very thinking and rigorous and serious. But sometimes, entire theories are rejected on the basis that they don't match our intuition, which is so odd because that seems to me like maybe some kind of moral judgment in sheep's clothes almost. Or it's just like such an unrigorous thing to say, to be like, we should, this, especially in like, I found in discussion of rights and liberties, if you accept a certain theory of rights, then maybe that doesn't grant rights to children. And people are like, well, that's a bad idea because that doesn't strike with our intuition that children at least should have some rights. It just kind of almost feels like maybe a cop-out of like, there's a stronger way to say that. There's maybe some truth that you could, I don't know, put more generally. But yeah, I don't know, the role of intuition in philosophy is kind of very strange. I don't know what you guys think about that.
I think it's problematic. There is this whole discussion in philosophy of medicine. It was basically started by this guy who tried to define what the disease is, and the way that he tried to define this is basically by doing this game where he was going with something like, okay, we give a definition. Does this disease enter in this definition? Then, okay. Does it not? But then we ask ourselves, is this something that intuitively we call a disease? Or is this something that intuitively could call maybe not a disease? Like, for instance, how do you call that? Like the thing of having a baby?
Pregnancy.
Pregnancy, yeah.
Yeah.
And so in that case, if we intuitively think this is not a disease, then the definition is fine. But if we think that this is intuitively a disease, then we need to change the definition in a way to put that inside. And the way that I was schooled about this is that it's extremely problematic. I'm kind of paraphrasing the way that my teacher said this. This is because basically this was a way where you were trying to do philosophy of medicine, which is a science, without looking at the science. So I think that the issue with the over-reliance on intuition of philosophy is when you try to not do just philosophy, but to try to do it in a way that's more applied to other things. And this also goes on when you don't look necessarily at science, but look at philosophy of politics. If you just like look at intuitions, you don't know political theory, you don't know what actually can go on and wrong about that. So it's good that we train our intuition, and it's good that we really make this our sharp weapon, but we need to understand when we can use it and when not. And we usually use it quite much, I think. So.
No, sorry.
It's just in like, I mean, yeah, I don't disagree, but in slight defense of philosophical methodology, I mean, I guess one thing which like, so these debates and arguments can do is they can build up connections. They can say, okay, if we adopt this definition, then all this stuff, you know, it's presented with options. You can sort of bite the bullet and live with a weird and unintuitive definition of disease, or you can go with something else and sort of, so, you know, at least there's some sort of, I don't know, objectivity. You know, you can trace those other connections, even if intuition, you know, is not gonna settle the matter. And I suppose, you know, like moral philosophy, we have theory and we have intuition. And that's, you know, we've got to.
I mean, my issue with that is just like, for instance, imagine that you do get at the end like a satisfying definition of disease, which is what was gotten out of that paper. I cannot remember the name of the other. Yes.
Christopher Boas, naturalist theory of disease.
And yeah, I mean, like, what do you do with that then? Because like, it's not something that a clinician would actually ever like use or look at, and at least not unless like under very specific or very general situations. And at the same time is something that like, yeah, I mean, it's interesting for philosophers to look at, to have like a pretty theory maybe that's very well reasoned. But the issue is like, if you want to just generate that, that's perfect. You're really using the philosophical instruments like you should. But if you want to do something that's somehow contributing to science, I think this is just not that good. And me, I prefer to try to do that thing, but this is just like a matter of personal choice at the end. I'm not trying to like shame people who instead want to stay inside the philosophical tradition, but for my personal I don't know, views or what I want to do with my life, I think I don't want to just stay inside of that.
I kind of think of like, I think building on what both of you were saying, I kind of think of one of the values of philosophy is in doing conceptual refinement, so getting more precise in our concepts so that we can more clearly apply them, and it kind of helps regulate communication. So if we're sure first that we're all speaking the same language in a kind of more precise way before we start asking questions about the world. But I also think that the methodology that you were describing, this kind of reflective equilibrium method where we like come up with a definition and then try to come up with counterexamples and then change the definition, and I think it works in many situations, especially those where the concepts seem to be up to us in some kind of way, maybe moral and political philosophy or like that. But in the sciences, I think that the content of what we're saying a lot of times is driven by the way the world is more. You know, like you don't want to come up, I do philosophy of physics a little bit more, but you don't want to come up with your like concept of charge just with reflective equilibrium, right? You know, you got to be quite familiar with how it functions in the theory and what role it's playing. And the world supplies a lot of that, I think. Like the content of our terms often comes from the world. And I think that should influence how our philosophical methodology too, especially when we're dealing with scientific concepts, which are so world dependent, so dependent on the way that nature provides things for us. But maybe in moral philosophy, it's like, okay. Are any of us, you maybe do more moral philosophy than Because you do value stuff.
I value stuff. I don't do any sort of hardcore like problem ethics.
Yeah.
But I was just thinking as you were thinking about, because I do some philosophy of race.
Yeah.
And I think race is sort of in the middle maybe, because
Yeah.
I mean there's maybe like a social science concept as well as like a political concept and stuff that I think it does involve, I mean, you do have to look at the social sciences, right? You do have to look at how people are using it and the sort of actual real phenomena in the world. But then there's also, I mean, a lot of the sort of metaphysics of race debate is this kind of reflective equilibrium methodology and intuitions. I suppose it's a space where you could say this conceptual engineering approach, as I did, because it ameliorate our concepts, make them better, has been relatively successful. Like, so this work, Sally Haslanger's philosopher, who's kind of suggested that we rethink race in terms of power, and obviously is come from several disciplines, so not just philosophy, but I think that's the kind of definition that's been, you know, disseminated into the world for a amount. So
I think this kind of idea comes up in philosophy of physics. People disagree about why we do it. But one view that's pretty popular is that we know that we're not at the final physical theory. And one of the things that led to modern physics in the early 20th century, with, you know, like Einstein and all those guys that you really like, is that they were thinking really clearly about what was then, you know, classical physics, what was then the top theory, and kind of picking apart the concepts and finding little, not inconsistencies, but bits of tension where it's like, how does this apply here, you know, and what are we going to, you know, why is it that the speed of light is the same as how things propagate in an electromagnetic field, and how does that all connect? And by thinking clearly about it, they came up with a better theory. And so I think some people in philosophy of physics hope that the conceptual refinement will enable physicists to better understand where they need to go next. I don't know for sure. I am more of a person who's comfortable just doing philosophy and being like, well, now we understand it better, I don't know what we'll do with that. But I know a lot of people in philosophy of physics who think that by sort of challenging some of the assumptions that physicists make kind of conceptually, they'll contribute to the project of coming up with a better theory.
And the cool thing about that is that at some point you find yourself in a spot where you're like, am I doing philosophy of physics or am I just doing conceptual physics?
Yeah. Foundations of physics is like that, where they're, you know, some people are doing very mathematical stuff and they're like, what if, you know, what would the theory look like if there were discretely many, you know, things instead of a continuum? It's like, I don't do that myself, but I love hearing about it.
Sounds like math to me.
Yeah, it is, I think, yeah.
Just quickly before you go, was there another question at the back?
Yeah, this is actually kind of on topic. I'm a mathematician, and I was just gonna sort of ask, to what extent is mathematics a branch of science? Because in the beginning, you sort of attempted to define what science means to you, and I was sort of thinking about maths, and it doesn't really apply to like a lot of what you were saying. Like, for example, my personal values don't really affect my conclusions that I draw. It's very like axiomatic and doesn't really have much connection to the real world. So yeah, I'm just kind of wondering to what extent is maths a branch of science, given that we rely on maths quite a lot in the scientific process.
I'll just say what I think, that you guys can be. This is a loosely held belief, so you guys can change. Don't feel like you will be offending me if you disagree. I think math is not science. I think math is like an a priori. I think it's an a priori discipline, and that it's. I think mathematical facts are robustly true and false, so it's objective in a way that science is. But I think it's more of a tool that's just incredibly useful in science. But like just doing pure math, I don't think is science. But just because it doesn't have any empirical content, because there's nothing that you're like learning from the world, and I think that's what science is. But I don't, you know, I'm not absolutely certain of that. You know, some branches of theoretical physics, it looks to me like they're just doing math, but they hope to find a prediction, you know, so maybe then that makes it science. Yeah.
What did you guys think, John?
Yeah, I think that's my instinct too, but it's one of the things where I'm sort of vaguely aware of some huge debate that I like to think about.
We're on record right now.
Yeah. But that's my intuition too, and well, I'm scared to say this because it might not be true, so I really don't know much about maths, but just in the values thing, I mean, at least my vague sort of knowledge of physics is that even if there aren't, I think, well, at least in like theoretical physics, there can still be like cognitive values, even if there aren't to be social values, like there can still be trade-offs with things like simplicity, or I suppose with physical theory, explanatory power, predictive power, things like that. So in that sense, like values can come into things that are quite abstract.
I think in some of the like foundations of set theory and category theory, people think there are values involved, and what axioms are the best ones to choose as the basic axioms for set theory, and there are different foundational ones, but like Zermelo-Frankel won out for some reasons that I don't understand because that's not my area. But I think in that way, yeah, there are cognitive values that are relevant in that still.
I guess like the only point at which values enter maths is like there are some things that are undecidable. Like this is a huge thing in maths, that there are some things that we can never know, what way the coin is gonna fall. And I suppose at that point then that is a choice. And then maybe you have some values that inform that choice. Thankfully that doesn't happen in a lot of points in maths, so usually we're kind of safe from like the value-free ideal, like we're kind of the only ones in science, if you'll let us in, that do well on that front. But yeah.
Okay, Tinka, you do math.
Yeah.
So what do you think?
I've been hiding in the corner.
Yeah.
I don't know. I've never really. I thought a lot about like what maths is, but never if I think it's science. I would, obviously this is a very biased answer, but I would say it's kind of above science because it makes science possible. It's kind of similar to what you said. It's like it's a tool almost. I would say it's science in the sense that like it attaches the same importance and rigor to how you obtain truth. But yeah, beyond that, it's very different and almost a lot more like philosophy in the sense that it can be done from the armchair. You don't have to go.
If I can say something, but saying that maths is not science is almost like saying that logic is not part of philosophy. I've studied engineering, and I know Isaac Newton, when he was pursuing his scientific theories, he developed calculus. So surely there has to be some very closely knitted semblance between the two things.
Which brings us back maybe to the idea that something is science if many scientists call it science.
The naming, yes. So we name it, yes.
Yeah.
I guess you bring up a really good point. Like maybe we can compare it to the way that maybe we wouldn't say that the alphabet is part of writing as such, because the alphabet makes writing possible. Like it's a building block, maybe. So maybe it's like, maybe it's the wrong question to ask almost.
Yeah. But I think it is really similar. I think, like math is to science as logic is to philosophy in a lot of ways.
Well, have you ever seen this joke where it's like maths is applied logic and physics is applied maths and chemistry is applied physics, etc., etc. And eventually you get to philosophy and you're so far away from anything else. Okay, I think that's a really great note to end the panel on. Thank you all for coming, and thank you again to all of our guests for attending. We'll all be going to the pub after this. We're going to the Tenants Pub. So if you want to join, you're all more than welcome. Thank you.